We're going to be meeting a lot of square roots as we work with quadratics. Let's take a moment and recall how we write a square root in the nicest possible way. What do we mean by the nicest possible way? When we're writing a square root, there are two things we want. We want the smallest possible number inside the square root, and we want no square roots in denominators. And in order to accomplish this, we're going to use two facts. The square root of a product is the product of the square roots, and the square root of a fraction is the fraction of the square roots. We may also want to have on our hands a reference to the first 10 or so perfect squares. If you know all of these, you know enough to simplify every square root we're going to ask you to simplify here. We'll meet more sophisticated techniques for accomplishing this later on. So, let's take a look at an example of simplifying a square root. What do we mean by saying a square root is simplified? We want the smallest possible number inside the square root. That means it has no perfect square factors. We'll say a square root is simplified when the number inside the square root has no perfect square factors, and the denominator of any fractions are all outside of square roots. So let's see an example of what it is we're trying to do and how we accomplish it. Let's say we want to simplify the square root of 50. So, going through our list of perfect squares, we notice that 50 is a multiple of 25. If you don't happen to see that you have a perfect square factor, you're allowed to go through and divide by every perfect square until something turns out to be a whole number. So we could go through and say 50 divided by 4, 50 divided by 9, 50 divided by 16. These will all be decimals, but 50 divided by 25 is 2. All right. So, armed with the knowledge that 50 is 25 times 2, we have the square root of 50 equal to the square root of 25 times 2. But now we have this property of square roots that says we can break this up as the square root of 25 times the square root of 2. 25 we know is a perfect square. 25 is 5 squared. So the square root of 25 is 5. So we have 5 times the square root of 2. And we can write that just by writing 5 next to the square root of 2. What do I mean when I say that the square root of 50 simplifies to 5 root 2? I mean, those are the same number. If I go to my calculator and I punch in the square root of 50, that's some awful decimal. But it's the same awful decimal that I get when I punch in 5 times the square root of 2. Right? See, these are the same. You can always check your work on simplifying a square root by comparing the decimal approximations. I'm going to give you one of these to try before we move on to talking about fractions. Simplify the square root of 48. Pause the video and try this now. All right, so maybe you immediately spotted that 48 is 16 times 3. If you did, then you said that the square root of 48 is the square root of 16 times 3. So it's the square root of 16 times the square root of 3. 16 is a perfect square. Its square root is 4. So we'll have 4 times the square root of 3. So maybe you spotted that and you got this answer. Maybe you didn't. Maybe instead you went through and divided 48 by every perfect square. 48 divided by 4 is 12. That's starting to look promising, but we shouldn't stop yet. 48 divided by 9 is a decimal. On my calculator, I got 5 point a bunch of 3's. So 48 isn't a multiple of 9. 48 divided by 16 is 3. And now what's left is a prime number. It doesn't have any factors at all. We can stop when what's left is a prime number. Or we can stop when we get past 48. Right? 48 divided by 25 is a decimal. 48 divided by 36 is a decimal. And then 49 is more than 48. So we can certainly stop there. Either way, once you had 48 divided by 16 is 3, you could go over here. Root 48 is root 16 times 3. All right, what about fractions? Let's say that we want to simplify the square root of 7 halves. Our first step is to multiply the numerator and denominator by something so the denominator is a perfect square. And unless we see some clever smaller choice, we're always going to pick the denominator to multiply by. So we'll have 7 halves is 7 times 2 over 2 times 2 is 14 fourths. Now we'll break up the square root using that property we saw where the square root of 14 fourths is the square root of 14 over the square root of 4. And notice if we did step 1 right, the number in the denominator is a perfect square. So the square root of 14 over the square root of 4 is the square root of 14 halves. And then our last step, if it applies, is to simplify the numerator. In our example, 14 has no perfect square factors, so we leave root 14 over 2 as our answer. Let me show you another example of this, and then I'll give you one to try. All right, so let's simplify the square root of 25 thirds. So I'm going to multiply the numerator and denominator each by 3. Remember, that doesn't change the value of my square root. So I'll have 75 ninths. I'll split that up, root 75 over root 9. I can take the square root of 9. It's 3, which I should have expected. And then noticing that 75 is 25 times 3, my final answer will be 5 root 3 over 3. All right, I'm going to have you try one of these now. Simplify the square root of 15 sixths. Pause the video and try this now. All right, so I'll start by multiplying my numerator and denominator each by 6. So I'll have the square root of 90 36ths. That'll be root 90 over root 36. That is root 90 over 6. But 90 is 9 times 10. Root 9 is 3. Oh, and I see one more move I can make, don't I? My numerator and denominator have a common factor of 3. And so my final answer will be root 10 over 2.